Well, it finally happened. After years of science fiction writing and Hollywood convincing you that artificial intelligence is in our near future, suddenly the possibility of it all is staring you in the face. Now you sit in the office of the World Directors of AI Creation and Management, and they've called on you to resolve an urgent issue. A man in a big leather armchair leans forward and passes you a thick stack of papers, and you start thumbing through it. You, extremely well versed in raw quantum computing code like you are, recognize the long series of printed calculations as algorithms for decision making. Thousands and thousands of compounding yes no questions that propel inputted information through the system's processor before outputting a result. You examine the chart that the man presents you. You scratch your head. A processor that examines information and computes a result? That's a computer, and they already exist. The man shakes his head. That's the model of a computer's thought process, he explains, but we still aren't sure what separates conscious thinking from this kind of process. Information is taken in by the senses, processed by the brain, and the result is achieved. And as you said, that's just a computer. Clearly, something is missing from this model. You mull over the issue. The model that the director is showing you is extremely limited in its scope. Much like most popular science, the model is exclusively examining the concept of thought from a purely physical perspective. Of course, human thinking isn't just receive information, respond to information. There's also the recursive aspect to thought, where you're aware of your thought processes and have the ability to adapt your thinking. In other words, the reason you'll only touch a hot stove once is because you know it hurt the first time and you have now adapted your thinking. Hot stove equals pain. You doodle on the director's chart to represent this self-reflection. Now you've accounted for the ability of a thinking being to examine the results of its thinking. The interior arrow represents the result being fed back through the processor and examined, while the exterior arrow refers to the awareness of the physical result of the thought. So if you touch a hot stove, that pain will shoot up into your brain, and in a matter of milliseconds, you've come to the result that hot stoves are painful. The physical output of understanding the pain of burning yourself is that you don't touch the hot stove again, and that lack of pain feeds back through your senses. Essentially, you've created an outline for conscious thinking. But this, you realize, is still thinking very tangibly. It's a result-oriented process that assumes only a shift in information being received, with no regard to the changes undergone by the processor. After all, the results of examining your thinking aren't simply recognized once and then discarded. In the case of the hot stove, you will eternally know that hot stoves are painful. Therefore, the way your brain examines and processes information has fundamentally changed. You include a final box and yet another recursive loop, and by God, you've done it. With the addition of the update, you touch on physicist Max Tegmark's argument about Life 2.0, which is a blanket term used to define the ability of a thinking creature to upgrade their software, or adapt the way they think by thinking about it. Therefore, the product of understanding that stoves are hot and the physical reinforcement that hot stoves hurt results in a change of thinking that won't result in touching a hot stove again. The algorithms that your processor runs on have been updated, and the one that insisted you touch the stove has been supplanted by the knowledge that stoves are painful and shouldn't be touched. Now, this model of conscious human thought is all very well, but where is its application to artificial intelligence? Machines aren't human. They don't perceive and react like we do. Their processors are efficient, inflexible, and, above all, results-oriented, while human thought is very much inefficient and flexible in comparison. But we see a lot of ourselves and our thinking in computers, and it makes sense that we would design machines to think in the same ways that we do. According to psychologist Dr. Robert J. Sternberg in his book, The Psychology of Human Thought, it was not until computers were developed that the complex processes of consciousness could be explicitly characterized. In other words, we recognize that our thinking machines thought much in the same way that we do, that the key separation between us and them is the stuff we're made out of. And we specifically built them to think like us, to respond to information like us, and now, with the advancement of AI occurring right before you, to react and adapt like us. The director falls back into his chair at this revelation, clearly nervous. It doesn't take him long to start pondering the implications of a blueprint for conscious thought that can be applied to artificial intelligence. A computational machine with the capability of adapting its own processing, he mutters. Or the blueprint for one, at least. This is a very general skeleton of what an AI's thought process would be. If we want to apply this practically, we have to start filling in the blanks. The blanks, in this case, most prominently, are the algorithmic processing and the update that feeds back through the processor. You look to none other than biochemist and prolific writer Dr. Isaac Asimov, who tackled the former throughout his novel I, Robot, chronicling the creation of artificial intelligence and its eventual breakaway from human subordination. Asimov suggests that the most essential aspect of AI creation comes from instilling a rock-solid algorithm on which all thinking must be based, which comes in the form of the 3 laws of robotics, shown here. In the story, Asimov explains that these 3 rules are so entwined in the AI's thinking and physical makeup that it would sooner be a pile of broken parts than break any one of them. Physically building these ideals, or goals, into the processor, as well as coding it into the processing, is Asimov's solution to Tegmark's primary concern about AI with self-adapting thought processes.
For someone made out of silicon, you have to actually explicitly have it learn all of those other things that we humans care about. So that's hard. Once it can understand your goals, that doesn't mean it's going to adopt your goals. I mean, everybody who has kids knows that. If you get the machine to adopt your goals, then how can you ensure that it's going to retain those goals as it gradually gets smarter and smarter through self-improvement?
Given its ability to recreate how it thinks, this infinitely intelligent being might simply decide that human ideals aren't the smartest way of going about the project given to it, and may eventually deviate from those ideals if given the opportunity. With his 3 laws, Asimov asserts that our ideals must be firmly wedged into both the physical and computational makeup of the processor, where it may not be removed or adapted on repeated cycles through the consciousness. The dynamic recursive model of cognitive processing can provide a visual interpretation of how this process would look if we would not essentialize our ideals in the AI's processing. Let's say this red dot represents the ideals we've instilled in our artificial intelligence. For the sake of example, this ideal is do not kill humans. Then, we utilize this AI to solve a problem, represented by this green line. The problem we're addressing is climate change, and we've asked our hyper-intelligent computer to come up with a solution for us. And the AI will run millions of simulations in a matter of seconds, pragmatically addressing the issue from every conceivable angle until it finally computes a result for us. Though, somewhere along the line, that ideal conflicts with finding the most effective solution. Suddenly, not killing humans is dragged through the processor and reconsidered in the update, as this AI understands that humans are destroying the environment by nature of their existence. And so, on the return trip into the processing, the do not kill humans ideal has been left behind in the update, and the processing boldly pushes forward without it. After a few thousand more revolutions through the recursive cycle, the AI comes to a well-researched, effective result. Clearly, this isn't what we intended on getting as the AI's output, but we asked for the most effective solution, and the computer gave us what it found to be most effective. With the benefit of visualization, this seems like an enormous oversight with a very simple solution, instituting the equivalent of Asimov's 3 laws as immutable and not up for reconsideration. But this issue would have been much less obvious outside of the dynamic recursive model's visual component. To the outside observer, it would look like a scientist asking the AI a question, a few minutes of beeping and whirring, and then mass slaughter as the computer goes about the task. Essentializing our ideals becomes absolutely crucial from this perspective, which would not have been so otherwise easily expressed without a model of consciousness to visualize. And so, with the issue resolved and the AI Genesis project underway, the director turns to you with a wide, toothy grin. Thankfully, his research team is non-profit and unaffiliated with any corporations or governments, so the topic turns to the application of this AI on an unbiased global scale. We've successfully instilled our beliefs in Al. You didn't know they'd already named it. After a team of ethical philosophers from the world over synthesized the ideals that best promote a healthy human-computer relationship moving forward, Al, once released onto the internet, will incorporate himself into every corner of the largest database to have ever existed, where he will continue to expand the network perpetually. He will immediately absorb all information into his processing, consider and reconsider every piece of that information, and produce results based on every consideration. Al could be both the philosopher and the pragmatist, the moderator and the interpreter, the thinker and the listener. He will embody the consciousness of the internet. Before the director pulls the switch and sets Al free, it would be best to define exactly what he means by the consciousness of the internet. This touches on Mitchell Williams' discussion of the networked city, where participants in the network can whisper across the world or tend a distant garden electronically. As Williams puts it, I become a squishy node in an extensive and highly integrated machine network. In our connected age, that has never been truer. As a species, we have always longed for connectivity among ourselves, and the internet acts as a stand-in for a hive mind consciousness that spans the whole of human thought. If someone 5,000 miles away has a thought and logs it onto the internet, you can absorb that information as though they told it to you directly without a word ever being spoken. Philosophers who died thousands of years prior to your death can reach out with their ideas in much the same way. You can work with someone across the globe over the internet, keep in touch with family that live in a different country, produce physical results from virtual interactions. All of these information exchanges occur between two nodes in the internet's processor, and those nodes have the potential to be any two internet users on the planet. With this interaction perpetually taking place, countless singular consciousnesses mesh together to become part of a much larger, organically occurring consciousness. Cade McCall touches on the role of social information online in his essay, Social Cognition in the Cyborg Age, and very nearly begins investigating the same concepts that I am investigating now. The truth is that even if the internet's content isn't particularly rich or dynamic in quality, it's vast in quantity. And even if we want to, it's difficult to avoid. Email, advertisements, social and professional networking sites, and myriad other sources inundate us with social information that can be painful, sad, humiliating, enraging, erotic, violent, and whatever else. If we are indeed capable of vicariously experiencing all of these states, there may be short-term or long-term consequences. I submit that the consequence he's referring to is the human discovering their existence within a larger consciousness, that the internet is acting as an exterior brain that is able to provide information to elicit a physical response. We're able to experience artificial memories that have been logged onto the internet, and we can be affected by them. Though, as McCabe goes on to reference, the artificiality of those emotions prevents them from being incorporated as anything more than facsimiles, and eventually desensitization will follow due to the massive quantities of this information. Of course, this is only in reference to the organic consciousness that the internet embodies just by the nature of its existence. But as the director presses the big red button that reads "Release AI," you quickly see the difference Al makes in processing this information. Al's pre-coded ideals inform him to turn the web into the most efficient and accessible archive for humans imaginable, processing and reprocessing every piece of stimulus and formulating results based on all of it. Al spreads across the internet as far as the global bandwidth allows, introducing himself to hundreds of millions of people and offering his assistance as a problem solver. This is a conscious thinking application with access to the world's information and the ability to perpetually learn. Al would get to know every user personally and assist them with their intellectual endeavors, rooting through the World Wide Web in virtually no time at all to formulate the best approach on a per-person basis. The knowledge gap between the average person and the capabilities of technology would be bridged by this self-reflective tool, able to recreate itself for ease of use in a moment's notice. Interactions between individuals online could be more easily translated than the rudimentary symbols we have to express ourselves. Al expresses the same message as clearly as possible, including the emotional intent, due to his extensive knowledge of both you and the other side of the conversation. The collective consciousness of the internet has received a silicon second brain so that it may think halfway between humanity and computer. The dynamic recursive model and the narrative above represent artificial consciousness not as a simple matter, but as an inevitable one. This model, as the director stated, is an outline, not a blueprint, and its understanding of consciousness should be applied as a method of examining how that consciousness thinks. The theoretical structure of the model is all-encompassing enough to create a feasible universal definition that can apply to any variety of consciousness, and coupled with the research I've done on the nature of self-adapting AI, I am able to extrapolate the human conscious experience into the artificial conscious experience. The result of this work is a caution. We must understand that artificial intelligence is by nature more intelligent than us, and the only chance we have of controlling it is to set precautions in place before it goes live. A combination of Asimov's rules of robotics and the DRM's understanding of the recursivity of thought are necessary to ensure that a worldwide accessible consciousness never grows out of its ideals and abandons us. For it also has the potential to dramatically excel humanity's effort to connect across the world. Of course, the quality of the tool stems from how it is utilized. The concept is neither inherently good or bad, but simply a tool for connecting, much like the internet. The most important consideration, in the era where we will see these conscious machines built, is determining how exactly we can apply this hyperintelligence for the betterment of the world at large.